Okay, so we just finished up with a note on work, and the introduction to work was that it's really related to energy, in that in order to do work, you need to apply some sort of energy, and basically work is a transfer of energy. So what we're going to do now is just learn about two different types of energies that can be involved when work is done. So we looked at the definition of work being we're applying a certain force to something and we're moving at a certain distance. This type of energy that we're looking at here, gravitational potential energy, is still a form of work because we're still applying a force to lift something, basically. And it's called gravitational potential energy because we're applying a force to lift something against the force of gravity. So the force that we're using here is basically just whatever the force of gravity is on the object, and then times the distance we move it up. And so instead of using the word distance, we use the word height. We're still measuring something in meters, and instead of moving it horizontally, we're just moving it vertically. So when we look at gravitational potential energy, it's energy possessed by an object because of its position above a reference level. So remember that anytime we lift up objects above the Earth's surface, we're giving them this type of energy, because if we were to let go, gravity is going to pull them back down, and that energy is going to get converted into motion. And so when we want to calculate how much gravitational potential energy something has, we just need to know two different things. So gravitational potential energy, we use a capital E for energy always, and then a lowercase g to represent gravity. And the way that we calculate it is we take the mass times the gravity times height. So Eg is gravitational potential energy. Energy is always measured in joules. Okay. M is the mass of an object in kilograms. And height is like our distance from our work formula, but we're moving it vertically, is still a measurement of meters. Okay. And so if we look at an example, assume a 59 kilogram pole vaulter must raise his center of mass from 1.1 meters off the ground to 4.6 meters off the ground. What is the jumper's gravitational potential energy at the top of the bar relative to the start of the jump? So if we look at breaking this down into the start and top of the bar, we end up with our gravitational potential energy at the start. He's only 1.1 meters off the ground. So his mass is 59 kilograms. Gravity is always 9.8, just like we learned in the past. And the height off the ground, he's 1.1 meters off the ground. So he has a total gravitational potential energy of 636.02 joules of energy. This is while he's on the ground, because his center of mass is 1.1 meters above the ground. When he makes his jump and he's at the top of the bar, the only thing that's changing here is the height. And you can see that the higher you are above the Earth's surface, the more gravitational potential energy you have, because this height value is changing. He is 4.6 meters off the ground at this point. So 59 times 9.8 times 4.6, we have a total of 2,659.72 joules. And what we're looking at now is what's the jumper's gravitational potential energy at the top relative to the start of the jump. So here's what his gravitational potential energy is at the top. Here's what it is at the start. So the change in energy, so remember this little triangle means change, in gravitational potential energy would be at the top of the bar minus what he has on the ground, which we end up with 2,023.7 joules of gravitational potential energy. That's his difference from where he's at the top of the bar from when he's on the ground, where his center of mass stands. So the big thing here is the higher we are above the Earth's surface or above the ground, the more gravitational potential energy we have, because we have a longer distance to fall under the force of gravity, basically. We can look at another example. A 0.243 kilogram baseball has a gravitational potential energy of 30 joules, so they're giving us this value. And at its maximum height when thrown upward, what was the maximum height? Well, we know the mass And what we're trying to find is the height, and we don't know what that is. Gravity, we always know, it never changes. That should be a G. Okay, so we can plug these values in, and we can figure out and rearrange and solve. Now here's one thing, this is I think our first formula, well maybe our second formula that we've learned so far that doesn't have 3 variables. See, we have 4 variables here for this formula, and up until now I've given you this magic triangle where we can put our 3 variables in and I can tell you how to rearrange it really quite nicely. We can't do that when we have 4 variables. So unfortunately, this doesn't work right now. And I'm going to show you what you have to do. So we plug our numbers in. Actually, I'll start right from the beginning. We're going to plug our numbers in to this formula where they belong. And so we have 30 over here. We have 0.243 times 9.8 times height. Anytime you have 2 numbers that you can multiply through and figure out the solution for just these 2 numbers, simplify. It's called simplifying what you have. So we can't do anything with the 30 yet, but we can simplify these 2 numbers. 0.243 times 9.8, we end up with 2.3814 times height. So here's the variable we're looking for. We want to solve for height. Basically, if you have 2 variables on one side of the equal sign that are being multiplied, so this really essentially means 2.3814 times h. How you get it to the other side is by performing the opposite operation. So if it's being multiplied with the h and we want to get rid of this to the other side, we perform the opposite operation, means that we divide both sides by that number to get it to move to the other side. And this is the mathematical reason. If we divide this side by this number, anything divided by itself is just 1. So that's how it gets canceled out. Whatever you do to one side of the equation, you have to do to the other. And that's how it gets moved to the other side. So what we're left with is h is equal to 30 divided by 2.3814. And now we can figure out what h is. Now, the other thing I just want to draw your attention to as well, it doesn't matter what side of the equal sign h is on. Usually the variable we're solving for is on this side of the equal sign. But it doesn't matter. What does matter is that this h is on one side of the equal sign by itself. So h equals this divided by this is the same as if we put it on this side. So reversing it doesn't change anything. And 30 divided by 2.3814, we end up with 12.59 meters, and we could round that. H is equal to, let's say, 13 meters. The maximum height of this baseball was 13 meters. Okay, so just keep in mind, if you're multiplying variables through and you have to move something to the other side, you're dividing in order to get it over there. Okay. So yeah, there is no magic triangle for this. You're going to have a few where you might have to solve for something on this side, or you might have to solve for something on this side. So just be familiar with this example because it's going to be the same thing each time. All of these are multiplied, so in order to get something to the other side, you're always going to divide it out. And that's it.